Today we are going to be using the Joshua Bardwell F7 flight controller. Josh Bardwell's new F7 with the dual gyro sensor meshing. And we're going to be building this Armattan Rooster DJI setup with the Caddx Nebula and the Zing 2208 1800 kV. And I will be showing you how to make that from start to end, from building to programming and getting it into the air for the first time. First things I'm going to go over is the tools that I'm going to use to complete this build. First thing is an 8mm socket just for taking on and off the props. Next is going to be the soldering stuff. TBS solder, some really high quality solder, definitely needed for good connections. Next is going to be the TS80 soldering iron. I like to use this just because it's small, it fits in my hands well. Some flux, it's just a flux pen. Pretty simple, easy to use. You press down on the tip and it allows flux to come out. Some squeeze apply tweezers. These can be found just for any jeweler basically. And just some precision scissors just for cutting wires. Along with my BatGo from ISDT. I'll power this through any XT60 connection and use that to power my TS80. I also like to double check my connection at the end using an ohm meter, basically a multimeter that can be used as an ohm meter, double checking to make sure that I don't have any short circuits on my build before I go and plug in for the first time. As far as gear goes, we are going to be building the 5-inch Armattan Rooster. This is an awesome frame. I've got 2 of these guys already. I absolutely love them. As you can see, I like to smash them also. Lifetime warranty does come in handy as far as crashing quads like this. I had my buddy print me up some 3D prints here. Got some arm protectors, some XT 30 by 30 to 20 by 20 mounts, some DJI camera mounts for the Armattan Rooster, XT30 or XT60 mounts for the battery strap, and then this would be from Brain 3D. I've got a GoPro 8 mount for the Rooster. As far as gear goes, this is what we're going to be using. As far as the flight controller, the JB Josh Bardwell F7 flight controller, just released to Patreons as far as this time goes. Then we will be using a Hobbywing 40 amp 4-in-1 ESC. I have this in a couple of my other builds. It seems to be reliable so far. I've got a Nebula kit from Caddx. We'll see how this goes. I may be swapping out this camera and throwing on a standard DJI camera just for the quality and functionality of it. I also like to throw a GPS module, HDLRC. This is nice to know where your quad is when you lose it. I'm going to be throwing an LED bar on this quadcopter. I don't normally do that, but for you guys in this build, I'm going to be doing that. I love the Grip for battery pull down. It's some really sticky stuff that you just throw on your quadcopter, and basically that stickiness helps hold your battery in place when you have your battery strapped down. Alright, as far as motors go, we're going to be using Zing 2208s, 1800 kV. These are really nice motors. I love Zings. They seem to be really high quality and really seem to take a crash really well. And as far as my antenna goes, I actually run right-hand polarized antennas on my DJI setup, so I am going to be using these Fox Ear Lollipop antennas. These are version 3s. These are straight to UFL. I seem to get the best video quality when I go straight to UFL, straight to the Vista unit, as far as not having any adapters in between these guys. I always seem to be using these Ethics props. I do live at higher altitude, so I do use the S5s a lot of the time. I love to get these from my local guys at WeSellQuadParts.com. That's pretty much all the gear I use. I record everything on a GoPro 8 Black, and let's get started with the build. I am just going to start taking everything out of its package and organizing. Another thing that these scissors come in handy for is opening packages. Let's get this Bardwell board out. We're going to be using these gummies, along with some of these wires. We'll see what we actually need. Going from the flight controller to the ESC. Whoops. And that is an interesting setup. If you're not used to seeing these boards, they are a little bit different from what you're used to opening. They are standard wires, XT60 connector, but then they have already taken the liberty of going and soldering on your XT60 leads to the board, along with soldering on a capacitor, a 35 volt 560 UF microfarad capacitor. It's going to be fun. Something needed in that. Now, I have never used one of these nebula systems on any of my builds, so it's going to be interesting to see the quality difference as far as going from the DJI camera to this little nebula. Don't want anybody stealing your nebula. Got this nice little pull tab in here. Alright, instructions. There it goes. This antenna I don't use. I've got stacks of left-hand polarized DJI antennas. Let's see here. Definitely going to use that to plug in. And let's see this little guy. Oh no, that is a little camera. That is tiny. I am not used to seeing a camera that small. Looks like everything is in order. They always seem to solder the positive and negative tabs. As far as quality control goes, they test every unit before it goes out, I believe at the DJI factory. And here's a little camera mount, also a little adapter. Looks like to bring that camera out to a normal size micro camera adapter. Alright, we've already seen the Zing motors. These are really nice motors, the 2208s, 1800 kV. And all the screws and all of the prop nuts. little LED strip, some wires to attach it. It's got 4 LEDs along with a buzzer. These are the pads right back here that you solder to. Got the HJLRC, U-blocks, GPS module with plug. Comes in handy for soldering a couple wires. Got a bag of bolts that I'm going to be using. Good old rooster frame. Alright, so we got 2 little antenna protectors. Got some little foam pad standoffs. We've got the front camera bar along with some assorted hardware. Have the rear antenna bracket end mounts. Got some Armattan stickers. This would be the body, bottom plate, top plate, camera plate, 2 arm plates for top mounting and mounting the arms, and then the 4 Armattan Rooster arms. They always give you a battery strap as well. This would be the front cage. Two side pieces. Titanium cages. Seem to hold up pretty well. I'm not sure if I've bent mine or not on my other quads. I've definitely bent the front bar multiple times. But they definitely take some hard hits. These would be the rear standoffs. They have these little grooves that allow the top and bottom plates to mount on them. And whether or not we use all these pieces, that will come to pass. These would be the 2 blocks that fit between the arms. They're called screw savers. Basically, when your arm takes a hit, rather than putting all the pressure on the screws, it allows the leverage of the 2 arms to basically pivot on these squares. I'll show you an example here in a second once I get some of these arms open. A little more structure than it used to be. Alright, so these arms, when they sit in the frame, they pivot against these blocks to help save the screws. So when the arm takes a hit and wants to bend, it will press against the center block. Alright, so first things first, we're going to be getting this rooster body together. I like to get everything out of the packaging. So Armattan gives you a battery pad, but I use the grip, and I also use my own foam pads, so we're not going to need any of these. And then also, Armattan seems to use a very thin, about 1.5 millimeter carbon fiber camera plate. And now this would slide through this GoPro mount and then attach to the quad with 4 screws on either corner. I tend to tear, rip, break, and destroy these little carbon fiber camera mounts, so I custom make my own aluminum mounts that slide right into the 3D print and allow my camera to be mounted on an aluminum mount rather than a carbon fiber. I have never bent, broken, or torn any of these aluminum mounts, and we will get to mounting that later. So as far as the hardware goes, I do always use the titanium center camera bar, and there are a few other components in here that I need. Then as far as the rest of it goes, I'm going to use a couple of these standoffs when mounting the flight controller, but I probably won't use much of that. I use my own screws, stainless steel screws with a larger head on them so that I get a little bit better tightening ability. These are M3 screws, stainless steel. Can be bought in a set on Amazon. I'll post a link in the description below to all these tools, all these parts, and anything else that I'm using in the video. So my screw package is right here. I have prearranged the screw setup, so this is pretty much everything I'm going to need for this quadcopter build. And we will start with the bottom plate. So these mount like so, and then the arm go right in between. Like that. And I always do the front arms first, just because they seem to be a little difficult to get to line up and hold in place. This is where I'm going to be using my Nanch precision tool set. Apparently Marky Mark used this in Transformers. It's the only reason I bought it on Amazon. The first couple times that you put screws through the carbon fiber, they may be a little stiff. You may have to go through a couple times. And same thing with the titanium. There may be a few burrs that the screw does not necessarily want to find its way through. And just make sure your screw holes line up on the bottom. Your titanium mount for your camera, your cage for your camera is secure. And one of the really nice designs of this frame is you only have to remove these 2 screws and the arm just pulls out, and you can replace the arm without having to disassemble the whole body of the quadcopter. Alright, so I'm just leaving these kind of loose. I don't have to tighten them all the way by any means as of yet. And I may need a little play as far as attaching other parts. Frontier bar. It's right between there. And on a lot of my builds, I will also come through and reapply Loctite to all these screws after I am done with the build. Most of them are still relatively easily accessible. And this is where that aluminum mount mounts. It's a little easier to see before the whole quadcopter is built. And now we are going to put the rear standoffs on. Alright, the rear standoffs are on. Forgot about the center plate that goes between the arms, like I was saying before. You can see that won't allow the arms to flex much. It will allow them to flex a tiny bit, but not as much as it would if that was not there. It would allow the arm to just crinkle back, basically. So this is where we use these top plates. This one is for the front, and it also encompasses the cage. This uses these little tiny self-locking nuts. They basically have a little biting end that will bite into the carbon fiber when you screw a screw through them, and they tighten down on the screw. They are a little bit of a pain in the neck to get them to line up the first time or two, but after you get used to it, they're not too bad. That's a longer standoff than I want. That was Alright, so continuing on here with our frame build. These are not fun to get in. Alright, now the front cage and front arms are built and assembled. Moving on to the back legs. These back ones I like to get the bolts started prior to mounting the arms. And just slide these guys on. And I'm just using my fingers on the bottom side to hold the bolts in place so they don't slide out. Oops. That goes like that. I can pinch this down. Try to line these up. And hold that with one finger while I tighten with the other hand. Got it. And I'm just lightly cinching these down just to get things lined up properly. If you tighten one down, the holes may not line up properly on the other 3 screw holes. This one doesn't want to cinch down. I'm just going to try a different one. Sometimes the threads are a little bit messed up on these builds. And the screws I'm using do not come with this kit. So that could be another factor also. The screws I'm using aren't the best build quality as well. Sometimes they have imperfections. Alright, so that's the initial frame. Oh, look at that. I forgot to put my screw saver in. So I can actually just show you how to remove an arm. And once these are tightened down for the first time, it usually does leave the self-locking nuts in position in the carbon fiber, so they usually don't fall out. Don't get me wrong, they will fall out if you bang it or something, but they do tend to stay in place for the most part. And then this just slides in here. That's also how you replace the arms on the rear. Just push that right into position. Slide this arm back in. And put the 2 screws back in. That didn't work. That's better. So I'm going to cinch these down a little bit harder on the rear because everything is lined up properly in position. And then your top plate mounts like this, and that would be your rooster build. And there are also the rear antenna components that mount back here, which we'll be using later, the antennas. But for right now, we are going to get onto the tinning process of pre-soldering our boards so that we can wire everything up properly. Alright, another component that we're using is the Team Black Sheep Crossfire Nano RX SE. Comes with the Immortal C antenna. I use Crossfire on all of my builds. There's the little Nano and the Immortal T. Those also come with soldering points and wires. Alright, this is the part of the video where I'm going to start to tin things and use the TS80 soldering iron. It's nice, it's little and portable, fits my hand nicely. Then I just power off any LiPo through my ISDT BatGo and power off USB. USB charge. That guy is on. Don't need it just yet. First thing is first, we are going to be using flux. Just press down on the tip and that comes out. So I flux everything quite heavily. Gives you a much better solder joint and allows the solder to flow much more easily and liquefy. Just going to hit all these pads that I plan on soldering to. Those are really tiny in there. A little Vista. And then on the Bardwell board, I don't really know exactly what I'm using, but I'm just gonna hit all these guys. Right. So we can start heating this up. I just use a simple damp paper towel to clean my soldering tip off. And my favorite solder is the TBS solder. It's high quality solder and it works well. If you were wondering why my glove is ripped, it's also because I need my fingernail to strip the ends of the wires that aren't already stripped and tinned. I go back over all of my wires just to ensure that they're properly tinned, and I like to match the solder with the solder that I'm using. You just get a better connection and better solder flow if you're using the same solder. Alright, so these are all ready and tinned. These are all ready. I'm just going to pre-tin all of this so it's all ready to go when I'm ready to solder. Alright, so my soldering iron's up to temperature. I usually solder at 400°C. The colder you can solder, the better. I just usually hit my points very quickly. Alright, so just a quick clean of the soldering tip. I always flux and solder my tip when I'm done using it, just to make sure that my soldering iron is not oxidizing while I'm not using it. You don't have to necessarily cover the whole pad on your first pass. You're just pre-tinning the pads and getting them ready to accept a wire. Alright, that's the ESC. Move that over. This is going to be really difficult for you all to see. just because of where the pads are located. I'm just going to start on the far end and just hit each pad. That's that. Just clean off your tip every once in a while. Make sure you get good solder points. A lot of people like to use a helping hand. It's basically tweezers on the end of a bendable device that allows it to help you hold your components. I really just like using tweezers. Sometimes it moves around on me, but if I'm moving the board enough to really move it drastically, I'm hitting the board too hard. And I just like to gently grab it where components won't be damaged. So as far as the JB board goes, I am going to need R3, I am going to need a ground and a 5-volt. That's going to be my GPS connection. Actually, I am going to put crossfire on this side, possibly. So I'm going to get another solder point on R5. I'm definitely going to need a 9-volt pad and ground for the Vista. I'm going to be doing a 5-volt ground LED buzzer and on this side I'm going to use my T1 and R1 for my crossfire, along with a 5-volt and ground pad. So this is going to be crossfire. This is going to be LED and buzzer and power for that. This is going to be power for the Vista. This is going to be receiving and transmission for the Vista. This is going to be power and ground and transmission. So when it comes to tinning wires, basically all you want to do is have the end of the wire exposed. I like to twist mine together. Some people do not, but I always recommend twisting the wire together. And then you basically just rest the wire on the soldering iron and just dab a little solder there just to get the solder to melt on the tip of the wire. And as you can see, the end of your wire is what they call tinned. Alright, now we are going to actually start wiring components up to the Joshua Bardwell board. Oh, wow. So, I just realized I don't need the 9-volt and ground pads because the plug for the Vista already has that. I just have to have it wired properly here on the actual Vista board. And then same thing, my ESC is going to be wired to my flight controller, so I don't have to do any soldering between these two points. Luckily this does have solder points below the plug here, and then Joshua also included solder points for motor pads on here, so the board can be rearranged so that you could solder and get connection to your ESC if by chance your plug did fail. Alright, so here we are going to be wiring up the Vista real quick, and it goes VBAT power, which these can be powered up to 6S, VBAT power, ground, R, and T. So we are going to use our tweezers here, clean off our soldering tip, Get a little bit of solder on, new solder on the tip, or soldering iron. And it doesn't take much to just touch it and make that connection. I missed a little bit, so I'm just gonna retry. And that's power. To do ground. Oh, and actually, before I do this, let's just take that off, clean that up a bit. A little bit too much solder on there. And I want to flux these joints. And I also want to add a bit of protection for my wires. I am not going to be using all 6 of these wires. I am only going to be using 4 because I am not using a DJI controller. I am using Crossfire, which does not require me to transmit and receive on that link on the Vista. So let's get this cleaned off again. Some fresh solder to the tip. Power. And ground. So an easy way to help remember which receive and transmission wire goes to which on the board, I always remember that 1 goes to R and T goes to 2. And 1 is usually the first in line on the plug, and 2 is usually second in line with the plug. That's not always the case, but that's usually the case. And that's the soldering for all those joints. I just like to bend them right underneath. And then this heat shrink tube will help it to wrap right around the side. And this is where I'll just use my handy dandy torch. Throw a little bit of heat there. And that's the Vista wiring. Now I also said I don't need these last 2 wires, so I will just remove them. Just grab the little scissors and poke here and pull up these 2 tabs, which allows me to pull these 2 wires out and discard them, and then I just push the tabs back down so it slides into the plug smoothly. Alright, and now this, if I did everything correctly, plugged directly into the board. These will be the wires that I use to go from the flight controller to the ESC. And this simply gets plugged in right here. And then I have to determine the wiring and match to this ESC the direction of the wires, or the order of the wires in which they go. So now that the Vista is wired, and the ESC is partially wired, I am going to wire up the wires for Crossfire. All right. So about to wire up the Crossfire components, or the wires for the Crossfire. So as far as the wiring goes, I prefer to put my wires on the inside of the flight controller, just so that they're a little bit more protected. And I've already tinned these, but I am just going to hit everything again with a little bit of flux again, just to make everything flow a little easier. Just gonna get a little more solder out. Clean the tip of my soldering iron off again. And I'm going to go perfect. Ground. I know a lot of people don't like using red and black for components other than power and ground, but that's what TBS gives you. So that's what I'm going to use. And so that goes to Crossfire. Next we are going to do GPS. These ends are a little long, so I'm just going to trim them. These wires as well. This heat shrink also helps direct the wires where I want them. I can just heat up the heat shrink and basically bend the wire to where I want it to be, which is convenient. And I just like to retouch bad solder joints, because why not? And sometimes I do that and make it worse than it was. All right. Give it a little heat. And that should be GPS wired up. All right. Now the wiring for the LED and the buzzer. I'm just going to make this easy. There we go with 12 volt. riser. We'll throw a little bit of shield on this, just to kind of keep the wires in order. Solder up crossfire. Go to tin these wires. And trim some of these up. Don't leave them that long. You also don't necessarily have to do 6 wires. You could get away with just doing 4 wires, but I'm going to set mine up to use pass-through. So I can use my phone's Bluetooth and my full-size TBS receiver to use pass-through through my flight controller to get beta flight on my cell phone. I will show you that later on. Some crossfire. I'm just going to do the same thing with the wires, just throw a little bit of protection on them, more so to keep things organized than anything. I don't really care about the wire protection necessarily. Alright. So now the 2 biggest components would be the power and ground. So I need to figure out which red and black wires that is. These 2 right here. And that's one of the reasons why I did this. I needed to have 4 different color wires over here so I can properly set up my pass-through. Or should I say easily set up my pass-through. Just gonna hit these with some flux. And on these TBS units, also I'm going to tin, pre-tin. These little components are extremely small, extremely difficult to see. They're very easy to knock off, very easy to damage. I've seen it done quite a few times. And just like that, you're tinned. So it goes ground, power. Very good to stay still. Ground. Power. And I just need to look at this. So 1 goes to R, which is going to be R3 black. And then red. And then yellow and white. These components are so small, I just like to use my own hands rather than having a helping hand. Alright, so now I have my Crossfire Nano, I've got GPS, I've got my LED buzzer, I've got my Vista, and now I just have to figure out the wiring order to make sure that my ESC and my flight controller are properly connected. So I'm just going to get some wiring diagrams up to show you guys. So basically, we've got the power and ground coming from the ESC. That's going to be powered from the battery. So power and ground are going to go directly to the flight controller and power the flight controller and power all these other components. Then we have motors 1, 2, 3, and 4, which are going to control all 4 motors on the flight controller. And we also have current sensing and telemetry, which is going to read the actual ESC data and send it back to the flight controller. Alright, so the setup's pretty easy for this because they give you a nice easy printout. So it goes on the plug, battery power, VCC, ground, current, telemetry, and then motors 1, 2, 3, and 4. S1, 2, 3, 4, signal 1 through 4. And then it shows you the motor outputs right here, which ESC is where, 1, 2, 3, and 4. So that's pretty easy to figure out. And then on top of that, the Bardwell board has a label on the plug. So it's very easy to be able to follow this diagram. So first is ground. Another thing you want to do when you're setting these little ends of the cables up is make sure that you're doing it the correct direction. So make sure that you're looking at how the pins go and how it's plugged in. So we're looking at this board basically upside down because it plugs in like this. And that's how the picture reads. So we want to go 2 over on this side for ground. You want to make sure that the pin is properly aligned. And sometimes they will push in. Sometimes you have to, there's a little sharp point to get them to click in. And make sure you're very gentle. I just felt it click in. And then just make sure, give it a little pull. You shouldn't be able to pull out easily at all. Alright, so that goes to ground on the front side, which should be the far side. That should be correct. Now we need power. So that would be bat, which is coming out right here. Second one over. This wire is going to go on the far side, but next to the ground. And I am trying to put it in upside down. Just use a sharp little point. I like to grab the edge of the middle if I can, and just push and slide in. And just to test with a little pull to make sure that it did click in place. You do not want your flight controller becoming unplugged or having a bad connection while you're flying. Okay, so now we're going to go for current, which is going to be the second to last wire on the board, the green wire here. I like to just kind of keep my wires a little bit organized and not mangled and meshed. So this is going to be the next wire in our loom. Seems like none of them want to slide in and click in on their own, so I have to use this little scissors every time. So after current, we go back here. We are going for telemetry, which is going to be the last, R4. If there's ever an R1, 2, 3, 4, 5, 6 on your ESC plug, that means that would be the receiving telemetry from the ESC. So So that's where you would program your ESC in the ports tab on Betaflight, which I will show you later. So next is going to be motor number 1. Motor number 1 is the white wire here. And I'm sure there's a proper tool for pressing these wires in, but I do not have one. And then we're going for M2, which is going to be the purple or bluish wire coming off the flight controller. Then 3 is going to be the orange wire.
Now to strike.
Motor number 4's input is the last wire. The brownish burgundy color wire. Alright, they seem like they're all connected properly. Plug this in. Alright, and now we are basically ready for assembly in the actual body. But first we are going to program everything. So I need to program the DJI. I need to plug in the flight controller, make sure it's working properly and that the gyros are responding along with any other sensors on board. I need to bind my crossfire to my receiver. So make sure your antennas are all on. You will definitely damage components on some brands if they do not have the antennas attached. Basically, you're trying to transmit and it doesn't have anything to transmit out of, so it just builds up massive amounts of heat, which causes damage to the components. And I need to throw an antenna on this Vista also, because that is going to be a big deal as far as not having an antenna on that while I'm powered up and trying to program. That requires you to loosen this screw right here on the corner slightly. You don't have to loosen it much. And there's this little tab you just press down, slide it over. That reveals the antenna slot. And I'm going to just gently clip this on. They're kind of a pain in the neck to get them to line up properly. Just be careful and press down firmly when you have it lined up. And you should feel it click. And it will also pop back off relatively easily. And it should spin when it's on there firmly and not fall off on its own. So I'm not even going to screw this back down, but basically this little component slides back over the antenna and then clips down underneath. There's a little tab that you have to push down and slide back under, and that will hold the antenna in place. So I'm just going to leave that off because I'm going to take my antenna back off after I test everything. I also do need to do one more solder joint right here for my XT60. I'll show you how to do that real quick. I still have everything all powered up over here. I just need to plug back in Get my XT60 out. I'm not going to be using these other wires from this kit. Just throw these over here. First things first, always throw your protector on. If you forget to put this on, obviously you can't do it after the fact. I am going to pre-tin these, even though they are pre-tinned already, and I am going to also pre-tin my actual XT60 connector. So how I like to do this, I'll put my joint so that it's angled so that I can throw my solder right in there and it tends to go down, slide down. You also want to flux this on both sides relatively well and make sure that your wires are well tinned. Alright, we're up to temperature. First things first, we're going to tin here. Don't be scared to have a lot on there. You want a really good connection here. And then here, like I said, you just kind of flood that port so that you've got a good amount of solder down pooling in the joint. And then they should be labeled on here. They are not, but the boxier side is always the positive and the negative is always the triangular side. You can see that right here on this battery. So, just go like this, throw this guy right on there. I'm going to flood the tip of our soldering iron with a lot of solder. And then just solder that guy right there. And same thing on the other side. Just flood the tip of your soldering iron with a lot of solder and press it on there. And you're good to go. These XT60 joints don't necessarily like a lot of heat, but they take a lot of heat to solder the joints. And I like to blow on them after the fact just to kind of cool them down quickly so they don't lose their shape. So now you can come back and that will click right over there. I'm going to use some conformal coat on all these components after I test them all. And then I will solder up the motors once I have the ESC and everything placed on the actual frame.